Hello, this tutorial is the atomic structure of chemistry by the S.A. Charles Review. We reference Cambridge International AS Chemistry by Laurie Ryans and Roger Norris. So this is atomic structure tutorial. And in this tutorial, our learning outcome is going to be identify and describe the proton, the neutron, electron in terms of the relative charges and relative masses. Deduce the behavior of beam of proton, neutron, and electron in electric field. Describe the distribution of mass and charge within an atom. Deduce the number of protons, neutron, and electron present in both atoms and ion given protons and nuclear number and charge. Describe the contribution of protons and neutrons to atomic nuclei in terms of proton number and nuclear number. Distinguish between isotopes on the basis of different number of neutrons present. Recognize and use the symbolism X, Y, A for isotopes, where X is a nuclear number and Y is a proton number. So let's start. So we need to point in our minds that we have to call what's called an element. An element, we need to know that is made up of the atoms of the made up of similar atoms with same chemical properties and physical properties. So this is what's an element, made up of similar atoms. At first, it was being taught that atoms were indivisible by the Dalton's theory, but now it has been seen that atoms are actually made up of some sub-fundamental particles, which are protons and neutrons. So this is what is going to be seen inside the structure of an atom. But we need to know that before it was very difficult to know that there were different subatomic particles. It has been a great thorough test time of through which has been done in order for us to visualize that the structure of an atom is actually a complex structure made up of shells and neutrons, as we're going to see inside the atom, structure of atoms. So now the structure of atom, the perspective of atom according to the Bohr model can be seen as such, where you have a nucleus and you have different circles as such, which are being called the cells. This is the nucleus and we have different structures as such called the cells. So the nucleus is made up of the proton and the neutron, and the shells are made up of the electrons. So the first point that I wish to put in your mind is that the electrons have been found by the man called J.J. Thomson. The nucleus has been found by the man called Ernest Rutherford, and the protons has been found by a man called Hansen. So these are the different points. So Max Hansen. So these are the different points that you have to put in mind. So the experiment of J.J. Thomson was that he emitted electrons. He made electrons to be emitted from the atoms by applying a heat on the atom. So electrons were emitted, and these electrons had different had a behavior on the cathode ray oscilloscope, where it produced a shadow on the fluorescent screen, as you're going to see in this part of the experiment with subatomic particle. The next experiment was the experiment of Ernest Rutherford. Ernest Rutherford did experiment. The people who did the experiment was Geiger. Who was the student of Ernest Rutherford, did the experiment in order to visualize if there was an existence of nucleus. And this experiment was based on irradiating the gold film with the alpha particles. And now he realized that most of these alpha particles were being undeflected, and little were being deflected at angle of less than of between 90 to 180 degree, and least were being deflected at angles of 180 degrees. So he concluded that the atom can be made up of a very small nucleus, which is made up of a high mass and also a highly positive charges. So this is a point to note here. So this is why the size of the atom can be compared in a stadium. The size of the atom can be compared as a small circle where the ball is being placed in a stadium. So that small circle where the ball is being placed in a stadium is compared as the size of the nucleus in an atom. So this is the generalized Bohr model of an atom. So now these are the different this is the experiment of subatomic particles. So for the electrons, we need to know that when you place this electric field, because electric fields are positioned here, here is the acceleration, so electrons are going to be accelerated in this direction. When you place electrons and you have positive, negative here and positive here, you realize that electrons are going to be deflected away from the negative plate and toward the positive plate. As it's going to be deflected, it's going to produce a shadow downward, but here you have a positive plate here and negative plate here. So you see that electrons are going to be deflected and they're going to produce a shadow up here. Now in case of a positive a proton or a positive ion, the deflection of the positive ion is going to be toward the negative and away from the positive plate, and it's going to be downward, while the neutron or a neutral atom is going to pass undeflected on this electric on this electric field. It's going to pass undeflected and going to produce a shadow at this position here. And we need to know that magnets also cause a change in electric field, and we need to know, according to physics principle, the movement of electron via electrostatic field is going to be unidirectional, while the movement via the magnetic field is going to be perpendicular. So that's why a magnetic field is always directed perpendicular to the movement of the ion in order for it to have an effect, while an electric field is going to be directed always parallel to the direction of the direction of the electric field in order to have an effect. So these are the points that you have to put in mind. So now we need to know, this is a beam of proton. The beam of proton is going to have a movement according to this positive. So you have positive here, you have here. This is, see that the beam of electron is going to move away from this positive plate. It's going to move away and it's going to move upwards toward the negative. So this is deflection. While for the neutron, the beam of neutron is going to move undeflected by this plate. So this is J.J. Thomson, who have identified the presence of electrons. So now the next one that you need to visualize is a number of nucleon, or the nucleon number. The nucleon number is defined as the proton number plus the neutron number. Then the proton number is said to be the atomic number, and this is a number which corresponds to each atoms in the periodic table. That is, it is the number that gives the chemical property of an atom in the periodic table. If you, the example, proton number of 1 or atomic number of 1 corresponds to hydrogen, atomic number of 2 corresponds to helium, atomic number of 3 corresponds to boron. So each of these give the chemical property of the atom, which enable you to have the different proportions in at the periodic table. So now we need to also visualize that when you have seen all the mass and charges of all these subatomic particles, in summary you can summarize these mass and charges of the atom and particles with respect to this. So electrons are going to be having a symbol E, and the relative mass of electron is 1 all over 1836, but the actual mass of an electron is going to be 9.31, 9.3 times 10 to the power negative 9.1 times 10 to the power negative 31. That's actual mass of an electron, 9.1 times 10 to the power negative 31. The actual mass of a neutron is 1.675 times 10 to the power negative 27, and the mass of a proton is 1.674 times 10 to the power negative 27. And the charge of a neutron is 0, when the charge of a proton is positive 1, but the actual charge is actually 1.6 times 10 to the power negative 19, and that of an electron is negative 1. These are the relative charge with respect to the atom. So let's come back to the nucleon number, where we said that the proton number plus the neutron number. So in order to know how many neutrons are there, it's only the atomic number minus the proton number. So these are the points to put in mind. So the nucleon number, let's say that the nucleon number is 51 and the proton number is 23. So it implies that for vanadium, 51 minus 23 is going to give you the neutron number. So now let's visualize again what are isotopes. We said that isotopes are atoms of same element, have the different nuclear number but the same atomic number, just to a slight variation in the number of neutrons. So these are what are called isotopes. So on the representation of B of X, an atom, a number here and a number below here. The number above here is the nuclear number, atomic number, and the number below here is the proton number or the atomic number. This is the atomic mass above here, and this is the atomic number below here, or the nuclear number above here. So now these are the points that you need to put in mind. So now this is for a hydrogen atom. So these are the different isotopes of hydrogen atom. Hydrogen atom can have one proton. The actual atom is protium. Protium has one proton and one electron. The next isotope can be deuterium. Deuterium has one proton, one neutron, and one electron. While the last one, tritium, has one proton, two neutron, and one electron. So these are the different isotopes of hydrogen. So now these are the different points. We need to know that how many protons, neutron, and electrons. So in this reaction, you see that chlorine has 17 protons, 17 neutron, electrons. So we need to know that what actually it has 17 protons, 17 electrons. But now when you gain one electron, it's going to cause chloride ion, and this has 17 protons and 18 electrons. But we need to know that the mass difference between chlorine atom and chloride ion is very negligible, because electrons are very, very small, and this is because their mass is actually 9.1 times 10 to the power negative 31, and you have seen their relative masses here is actually 1 all over 1836. So compared to the neutron and the proton, it is actually 1 all over 1836. So it is 1 all over 2000. So it's 2000 times negligible as compared to that of a mass of an electron or mass of a proton. So from here we can conclude the chapter of atomic structure. So, and now there's one point that I need to put again on the chapter of atomic structure, is that we need to put in mind that the Bohr model, which is actually the model that is shown here, is not actually the formal model of the atom. So we need to visualize, know that there's a different model, and a more performant model than the Bohr model, which is called the Schrödinger model. In the Schrödinger model, you see the Schrödinger model as having actually Schrödinger equation was having an equation which represented the atom in a three-dimensional space. In this Schrödinger model, I'm going to show you the introduction of the principal quantum number, the azimuthal quantum number, the spin quantum number, and the magnetic quantum number, which is being used in the electronic configuration of the atom. So from here we say thanks for your kind attention. Please don't forget to like and subscribe for the channel. Thank you.